Ale, last time we have started different Born-Haber cycles, right?
Yes, sir.
Okay. So today again, we did the same thing. Past paper. To chemistry, past paper. Yes. Now, last time we have completed 2023 papers, right? Yes. This is question number 75. And this is year number, yes, again, 2023, February, March, right? 2023, February, March, variant 42. So, can I start?
Yes, sir.
Okay. Complete figure 1.2 to show the Born-Haber diagram for the ionic solid zinc sulfide, right? Include state symbol, right? Now you have zinc. Okay. So here you have zinc. So first atomize it, right? So you know that here zinc is solid. So first we convert zinc solid to zinc gaseous. Zinc gaseous. Then we convert into ions. And then we convert into zinc plus 2. Are you getting my point?
Yes, sir.
So this is first ionization energy of zinc. So do you find any mistake in it?
So it will be Zn plus 1, right? For the
Yes,
first
very
time.
good. It is Zn plus 1 because it is first ionization energy. Now you can see that here we have sulfur, and then you convert sulfur into sulfur gas. So first atomize it, it convert into sulfur gas. So here we have sulfur gas. Here we have sulfur gas. Can you find more mistake in it? Yes.
So sulfur will be in the gaseous state, right?
Yes, here sulfur is in gaseous state. Yes.
No, sir, like because they already gave sulfur in the gaseous state in the top row.
Yes, it convert into sulfur gaseous, right?
So, sir, there's no
So
mistake.
it's no mistake. Right. Now look at the whole cycle and find more mistake in it. Yes. Try to find. Yes.
So I can't find any here.
Okay. Now look at the red one, right? First of all, this place is for zinc. So first write zinc solid and then write sulfur solid. This is our starting point, right? This is our
Yes.
starting point. So first we convert zinc solid into zinc gaseous. So this is zinc gaseous. Sulfur remains solid. Then we atomize sulfur. So here's zinc remain gaseous and here we have sulfur gaseous. Then one electron is removed from zinc. Then zinc plus 2 is formed. Plus 2 or plus 1?
+1, sir.
Plus 1 is formed. Sulfur gaseous remain. Here you can show this electron which is removed. Now this electron is given to sulfur, right? Will be given to sulfur. Now again one electron is removed. Again one electron is removed. So you have Zn plus 2. Then these two electrons are given to sulfur step by step. Here we have one electron. This is first electron affinity. Then give it to give it again. It becomes S minus 2. This is second electron affinity. When these two ions combine, zinc sulfide solid is formed. This energy is called lattice energy. When element combined, zinc sulfide is formed. This is called formation. Yes, Alia.
Yeah. Sir, I have a question actually.
Yes, yes.
Um, so like when we were taking the notes, we did it a bit differently, right? Like we started from zinc and then the sulfur separately. So we had two separate cycles running in parallel. But here they have combined it and they're writing with plus signs. So they're even adding the electrons here.
Hmm.
So both of
So
them are correct.
Bijay, sometime way may be different, right? For example, here electrons are given, right? Two electrons are shown, right? And here one electron is given again. Here two electrons are given, right? So these are not important, right? So either to remove electron from the zinc here, right? It is not shown. So doesn't matter, right? But the cycle is remains same in each case, right? In this case, you have two electron affinities, right? First electron affinity is downward, second electron affinity is upward. Are you getting my point or not? Are you confusing about these two lines?
No, no, sir, that's clear. Okay.
So first, in our initial cycle, we use two arrows, right? First arrow for the zinc and second arrow for the sulfur. But here examiner use single arrow to confuse us, right?
Yes.
So it's your wish. Either use single arrow or use separate arrows for zinc as well as for sulfur, Ni.
Okay, sir.
Okay. Now, can you define what is electron affinity? Do you know what is electron affinity?
So it's when 1 mole of electrons are added to an atom. So,
Gaseous atom to form gaseous anion minus one ion, right? Now
yes, sir.
we are moving to electron affinity, right? I think we have discussed. No. Now let's start electron affinity. Electron affinity. Now let's suppose this is chlorine gaseous. Now one electron is given to this chlorine atom, gaseous atom. So chlorine negative gaseous is formed. This reaction is exothermic, energy is released. This energy is called electron affinity. Now write the definition of electron affinity. The enthalpy change when 1 mole of electron is gained by gaseous atom to form gaseous minus 1 anion. To form gaseous minus 1 anion. Such enthalpy is called first electron affinity. This is point number 1. Now, Alia, can you give me example of oxygen?
So, sir, oxygen in the gaseous state
Oxygen
plus
is oxygen atom or molecule?
atom, sir,
Atom. Okay. Then
plus electron gives O minus in the gaseous state.
O minus in the gaseous state. Delta H is negative. Very good. Beta, can you give me example of sulfur?
As gaseous plus electron
As gaseous
gives
plus electron,
it gives S minus in the gaseous state.
S minus in the gaseous state, delta S negative. This is electron affinity, right? Electron affinity. Electron affinity. Can you tell me you know that chlorine is diatomic, right? Can you tell me what is how many number of atom in sulfur?
So one atom.
Do you know that chlorine is always bimolecular, right? Cl2. Phosphorus is P4. And
So
what
sulfur
about the
is 8.
sulfur? Sulfur is S8. Very good. Now, can you tell me, is it correct to write in that form? or write in this form? Which one is correct?
So the first
Yes.
one,
First one is wrong because it is not an atom. Atom is required. Atom, gaseous atom is required. It is molecule S8. It is molecular state, just like Cl2, O2, S8, P4, all are molecular state. Are you getting my
but
point?
if it's a molecule, it can't be an atom. Can be.
Okay. So this is wrong. So give. So how many electrons are required?
So 8 electrons.
8 electrons. Very good. 8 electrons. It become 8s minus gaseous. So this electron affinity is minus but 8 times because electron affinity is because electro because electron affinity is for one atom, for 1 mole. For 8 moles it should be multiplied by 8. Ali, are you getting this point?
Yes, sir. Okay.
Now next is, what about P4?
So it will be 4p gaseous.
So is it correct to write P4?
No,
One
sir.
electron is given, 4p is formed gaseous. Yes, this is
So
wrong.
it's wrong. So we'll write 4p gaseous.
Yes, 4p gaseous. How many electrons are required?
4 electrons.
4 electrons. 4p minus is formed gaseous, and electron affinity will be multiplied by, yes Alia, it would be multiplied
By 4, sir.
by 4 by 4. Now right, next point. First electron affinity is always exothermic. Can you tell me why?
So because energy is released, because the electrons are attracted to the nucleus, to the protons in the nucleus.
Because this energy is released because of the attraction between nucleus and positive nucleus and negative electron. Have you discussed this electron affinity earlier?
No, sir, not earlier.
Okay. Because energy is released when negative electron is attracted by positive nucleus. Due to electrostatic force of attraction, energy is released. Force of attraction energy is released. Alia, can I move forward?
Yes, sir.
Okay, next is second electron affinity. Next is second electron affinity. Okay, same definition, same definition, but with few changes. Now, the enthalpy change when 1 mole of electron is gained by gaseous minus 1 ion, minus 1 ion to form gaseous minus 2 ion, anion. Such enthalpy is called second electron affinity. Are you getting my point?
Yes, sir.
Now, example. This is chlorine, gaseous. Now, 2 electrons are given. It becomes Cl minus 2 gaseous. Yes. Is it second electron affinity?
No, sir. It has to be Cl minus 1, right?
Is it correct?
No, sir, it's not correct. It has to be Cl minus 1.
Yes. So this is the sum of first and second electron affinity, right? So this equation is sum of EA1 plus EA2. It is not second electron affinity. Second electron affinity is Cl minus 1 gaseous plus electron Cl minus 2 gaseous. This delta JH is electron affinity second, and it is positive. Can you make for the oxygen?
So, sir, O negative gaseous plus electron gives O minus 2 gaseous.
Can you repeat?
Sir, O minus gaseous plus electron gives O minus 2 gaseous.
Okay, O minus gaseous plus electron O minus 2 gaseous. This is called second electron affinity, which is positive. So why second electron affinity is always endothermic? Yes.
So there are repulsive forces between the electron and the negative ion. So energy is required to overcome the repulsive forces.
Repulsive forces to get an electron.
Yes.
Okay. So why second electron affinity is always endothermic? Because electron is negative, anion is negative, they repel each other, they repel each other. To overcome this repulsion, energy is required to get an electron. That's why direction of second electron affinity is upward and direction of first electron affinity is downward. So this is the direction of first electron affinity and this is the direction of second electron affinity. Are you getting my point?
Yes, sir. So,
Okay.
sir, for second electron affinity, the equation for S8 and P4 will be different again.
Yes. Again we have to multiply, but the same, but we just multiplied by 8 for sulfur. And for phosphorus, we have to multiply it by 4.
Okay, sir. So, why didn't the same apply to diatomic molecules like chlorine and oxygen? Because they also
Yes, same.
exist as O2 minus.
Yes, same for the chlorine. Same for the chlorine and same for the any element, right?
No, but like, sir, for chlorine, we just took Cl, right? We didn't take two Cl
It
dashes.
it 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 depends on the cation, right? For example, if you have Al, so aluminum, so we have AlCl3, so we have to multiply it by 3. If you have Al2O3, same for oxygen here because aluminum. But for calcium oxide, you have only one oxygen. We will discuss later, right?
Okay, sir.
Now move again to Born-Haber cycle. Describe the trend in the first electron affinity of group 16 element sulfur to tellurium, right? So periodic trend, right? So next heading is periodic trend of electron affinity. Yes, look at the periodic table, right? For group 16. For group 16. Look at the group 16. Oxygen, sulfur, selenium, tellurium. This is group 16. Yes. Can you tell me down the group? Charge is increasing or shell is increasing?
Sir, the shell is increasing, charge is the same.
Okay. So down the group, atomic size. Just remember, we are talking about the first electron affinity, right? Down the group, atomic size increases. First point. And what about the nuclear attraction?
So it stays the same.
Down the group, nuclear attraction remains same as shell
Also,
increases.
it will decrease, sir. The shielding
Okay.
is increasing, so it will increase.
So shell increasing, shell increases, shielding also increases. This is point number two. So as shielding increases, nuclear attraction decreases. Nuclear attraction decreases. Now predict, electron affinity increases or decreases?
So it decreases.
Decreases. Electron affinity decreases. Electron affinity decreases. Now this is down the group, right? This is down the group. Now across the group, across the period, sorry. Now across the period. Now Alia, can you tell me across the period proton number increases or shell increases?
So proton number increases, shell remains the same.
Very good. Proton number increases, shell remains same. Sorry, proton number increases. And what about the nuclear attraction?
So it will also increase.
Okay. Nuclear attraction increases. Nuclear attraction increases. Shell remains same, shielding remains same. Shell remains same, shielding remains same. Shell remains same, shielding remains same. So can you tell me what about the electron affinity as the proton number increases?
So electron affinity will increase then
Very
across
good.
the.
Electron affinity increases. Electron in affinity increases. Now, next, as I told you, DI means doctor instruction, right? Doctor instruction means DI means short tricks or very important point, right? So can you tell me first electron affinity is positive or negative?
So it's negative.
Negative. So first electron affinity is negative. So if electron affinity decreases, so negative value increases or decreases?
So it will decrease.
It will decrease. So down the group, first electron affinity decreases. It means less negative, and less negative means less exothermic. That's why electron affinity decreases. Are you getting my point or not?
Yes, sir. I'm getting it.
So, so describe the trend in the first electron affinity of the group 16. So now can you, for 2 marks? Yes. Now give the answer.
Sir, down the group, shielding will
Hmm.
increase.
Down the group, shielding will increase. Down the group, shell increases, shielding increases. Okay.
The nuclear attraction will decrease,
Nuclear attraction decreases. Okay, then
while the nuclear charge remains the same. So the electron affinity will decrease down the group.
no need to mention the nuclear uh, charge or nuclear density, right? As you know that down the group, nuclear charge also increases, but dominating factor is size. That's why do not write the word or sentence nuclear charge. Nuclear charge always increases across the period. Shell increases, shielding increases down the group. Are you getting my point?
Yes, sir. I'm getting it.
So down the group, shell increases, shielding increases, shielding increases. Point number one. Point number two, nuclear attraction decreases. Hence, electron affinity decreases, less negative, less exothermic, less exothermic. Are you getting this point?
Yes, sir. I'm getting it.
Now, next is comparison between latest energy, or you can say that compare latest energy. Comparison of latest energy. Have we discussed it?
Yes, sir. We have.
Okay. Do you know what are the two factors? Can you explain?
So the two factors are the charge of the cation and the anion,
Very
and the
good.
size of the anion.
Okay. So which one is directly proportional? Which one is inversely proportional?
So charge is directly proportional and size is inversely proportional.
Okay, very good. Now move to past paper again. Now you have zinc oxide and zinc sulfide. Can you tell me which element is cancelled out?
So zinc is cancelled out.
Okay. So you have oxygen -2 versus sulfur -2. Now which one will be cancelled out?
So the
Which
charge is
things
the same, so charge
charges?
will be cancelled out.
Charge will be cancelled out. So only factor is size. So here you have. So which one is smaller?
So the oxygen is smaller.
So which one has more latest energy?
So oxygen will have more energy.
Oxygen. Oxygen means zinc oxide.
Zinc oxide. Sir.
So why zinc oxide has more?
So because the size of O minus 2 is smaller than S minus 2.
Exactly, exactly. So this is for 2 marks, right? So because size of oxygen 2 minus is smaller than, you can use the word radius, size of S2 minus, because size of O2 minus is smaller than size of S2 minus. This is point number one. Point number two, distance between Zn plus 2 and O minus 2 is smaller than Zn plus 2 and S2 minus. So which one has a strong electrostatic force of attraction? So which one has a strong electrostatic force of attraction?
So Z and
Zinc,
two will have.
Zn plus 2 and oxygen. So strong electrostatic force of attraction between Zn plus 2 and O minus 2, then Zn plus 2 and S minus 2. Yes. Are you getting my point or not, Bete?
Yes, sir, I'm getting it.
Okay. Next is entropy. This is not entropy. Yes, we have completed. This is very solvent in water. Okay. Latest energy we have discussed. Yes, can you tell me the equation of AGBR for latest energy?
So Ag plus gaseous uh, plus Br minus gaseous gives AgBr solid.
Very good. AGBR solid. Now this is Born-Haber cycle. Can you solve and send the solution to my WhatsApp number?
Okay, sir.
First, draw the Born-Haber cycle.
Okay, sir.
Beta, I need only Born-Haber cycle, right?
Yes, sir.
Have you done?
Yes, sir, I've made the cycle. So you need only the cycle or the calculation as well?
Only the cycle.
Okay, sir. Sir, I sent it.
Mm, Ali wrote negative for two times, right? Can you explain why you wrote minus e two times?
Oh, so that's a mistake. It should be only one
Okay,
time then.
okay. Now, can you tell me what is H1?
Sir,
Can you
atomization
identify
of
atomization of silver? So, what would be what is its value?
285, sir.
285 or 112? 285. Okay,
Yes.
285. And what about the H2?
First ionization energy of silver, so
Okay,
731.
731 value. Very good. And what about what is H3?
So atomization of bromine,
Atomization of bromine.
so it's
So
so
atomization bromine
112
is
divided by
112.
2 times 1.
But it is because 112 is atomization energy, right? Atomization is energy is directly given. So no need to use the formula bond energy divided by 2 multiplied by number, right? So we use this formula when atomization is not given. Earlier, this is my DI. Whenever atomization is not given, you will use bond energy divided by 2 multiplied by the number which is written as a coefficient of Vr or any non-metal. Are you getting my point?
Yes, sir.
Okay. So then write this. Electron is given to this. So this is Br minus gas. Now, can you tell me the what is it? This is H4. Can you tell me what is H4?
So electron affinity of bromine,
Yes. Can you tell me its value?
so minus 325.
Minus 325, right? So silver is here. Now they both can form ionic bond, solid. This is H5. Can you tell me the name of this H5?
So its lattice energy, it's not given, so it's X.
So it's X. Yes. What is this? This is H6.
So it's
Yes.
the
What is
formation
H6?
of formation of
Formation.
AGBR. So
So
minus
it
100.
is minus 100. Now, can you tell me the formula used to calculate lattice energy here?
So H6 is equal to H1 plus
Very
H2
good.
plus.
H1 plus H2 plus H3, sum of all enthalpies. Okay. Now H6 is given, which is minus 100. H1 is 285. H2 is 731. H3 is 112. H4 is minus 325 and X. So can anyone tell me the value of X?
Some minus 903.
Minus 903 kilojoule per mole. Minus 903 kilojoules per mole. Now, can you compare these two, AgCl and AgBr? Can you tell me which factor is cancelled out?
So silver is cancelled out.
Silver is cancelled out. So silver will be cancelled out. So you have Cl minus and Br minus. So which factor again will be cancelled out?
So charge will be cancelled.
Charge will be cancelled out, right? So the only factor is, yes, which
Size, sir.
factor is size? So which one is smaller?
So Cl minus is smaller.
So which one has more lattice energy?
AgCl will have more energy.
AgCl. AgCl has AgCl has more lattice energy than AgBr because size of chlorine minus is smaller than Br minus, less distance between Ag positive and Cl negative, hence strong electrostatic force of attraction between them. Attraction between Ag positive and Cl negative. Yes, do you have any question?
Um, Sir, these 4 marks are only for part 3 or is it
No,
for all
this
the
is 2 marks. Um, Hardly 2 marks for it. Remaining for the Born-Haber cycle.
Okay, sir.
So, next question. Yes, define lattice energy. Yes, define lattice energy.
So it's when 1 mole of an ionic compound is formed from gaseous ions
But try
and
to
that
start from the enthalpy change, right? Enthalpy change when 1 mole of ionic solid is formed. Is formed from gaseous ions. From gaseous ions. From its gaseous ion. Now, now compare magnesium sulfate and barium sulfate. So which factor will be cancelled out?
So charge will be cancelled out.
First sulfate cancel out and then charge cancel out, right?
Yes, sir.
So size. So beryllium, magnesium, calcium, strontium, barium. Yes, which one is smaller?
So magnesium is smaller.
Okay. So which one has high lattice energy?
So MgSO4.
MgSO4. So lattice energy of barium sulfate is less than lattice energy of magnesium sulfate. This is for 1 mark. Second mark, due to larger radius of Ba2 plus, due to large radius of Ba2 plus. Are you getting this point or not?
Yes, sir, I'm getting.
Alhamdulillah. Now next is question number 8. Yes. Now can you tell me the latest energy equation of calcium chloride?
So Ca2 plus gaseous
Ca2 plus gaseous,
plus 2Cl minus gaseous
2Cl minus gaseous
gives CaCl2 solid.
gives CaCl2 solid. Correct. Now next, compare the latest energy of calcium chloride and calcium fluoride. Calcium chloride versus calcium fluoride. Yes,
So
which
calcium is
factor?
cancelled out
Calcium is cancelled out, right?
and charge is
Charges is
also cancelled.
charges is cancelled out. So the only factor is size. So fluorine, chlorine, bromine, iodine. So which one is smaller?
So fluorine is smaller.
So which one has high lattice energy?
So calcium fluoride.
So lattice energy of calcium fluoride is greater than lattice energy of calcium fluoride. Why? Because size of fluorine is smaller than size of chlorine. Size of chlorine. Now, what about the calcium chloride and calcium sulfide?
So we cancel calcium and charge again.
No. Charges is not cancelled out. Here we have -1, sulfur has -2. So charges are not cancelled out. So which one has high, strong lattice energy?
So calcium sulfide will have a high lattice energy because the charge is greater on the sulfide.
Because charge is greater. Very good. Calcium sulfide. So lattice energy of calcium sulfide. Lattice energy of calcium sulfide latest energy of calcium sulfide is greater than calcium chloride because S minus 2 has more charge minus 2 than Cl minus 1. Yes, now you have to draw the Born-Haber cycle of calcium chloride. So you have calcium solid and chlorine gaseous. So first we convert, yes.
So sir, we'll atomize it. So Ca gaseous,
So first Ca gas, then
then Ca plus gaseous,
Ca plus gaseous,
then Ca2 plus gaseous.
Ca2 plus or plus 2. Now this is H1, this is H2, this is H3. Yes, chlorine,
So we convert it into 2Cl gaseous.
2Cl gaseous, 2Cl gaseous. Yes, what is it? H4. H4. Now electron is given to Cl minus. So calcium remain plus 2 gaseous and chlorine become negative. Now these two combine and form calcium chloride to solid. These two combine. This is H5, H6, H7. Yes, can you tell me the values? Yes, Alia, can you
Sir,
tell me the
H1 is
values? H1 is
178, sir. Atomization
17,
of
okay, 178. Then H2 is, so H2 is not written here, right? So this question is older question. So you have to use data booklet, right? So I am giving you the first electron ionization energy for. Do you have data booklet?
no, sir, I don't. Okay.
Okay. So first ionization energy of calcium is 590, and second electron of ionization energy of calcium is 1150. 1150. Yes. Now you can tell me the value of H2. Yes.
So sir, H2 is 590 then.
H2 is 590 and H3 is
1150.
1150. What about the H4? Atomization of chlorine.
Sir, we don't have that.
Okay, so bond energy is required. So again, bond energy is given. Bond energy is required. So we will use periodic table as data booklet. to find the bond energy, which is 242. Now, can you tell me formula of H4 when atomization of chlorine is not given?
So bond energy divided by 2 times 2.
Okay, very good. Bond energy divided by 2 multiplied by 2. Okay, what about the H5?
So electron affinity, so minus 349 times 2.
H5 is first electron affinity or electron affinity, right? So electron affinity per mole is minus 349. It should be multiplied by 2. Am I right?
Yes, sir.
Because you have 2 chlorine atom. So now what is H6 and H7?
So H6 is lattice energies. We have to find, so it's X.
Okay, it is X. And what about H7?
H7 is minus 796.
Minus 796. So what would be the formula? H? Yes, can you tell me the formula?
So H7 is equal to H1 plus H2 plus H3, 4, 5, 6.
Plus H5 plus H6. Now H7 is minus 796. H1 is 178. H2 is 590. H3 is 1150. Then 242 minus 349 multiplied by 2. Z plus X. Yes, I need the value of X.
So minus 2096.
Minus
2016.
2020.
16.
Wrong. Yes.
So minus 2258.
Minus 2258. 2258 or minus 2260 kilojoule per mole. Minus 2260 kilojoule per mole. Can I move to another question?
Yes, sir.
Now this is question number 9. Draw bond cycle. Yes. Alia, can you help me to solve this question along with the bond cycle?
Yes, sir.
Yes.
So we'll start with BA solid.
Okay, be a solid. Then
So it will become BA gaseous.
be a gaseous. Then
Then BA plus 1 gaseous. Then BA2 plus gaseous.
yes. This is H1. This is H2. This is H3. Yes, can you tell me the values?
So H1 is 279. No, sir, 180, sir,
H1 is
180.
180, correct? Correct. Then H2.
So we don't have H2 and HD. Okay.
So data booklet is required, right?
Yes, sir.
So first ionization energy of barium. Yes. First ionization energy of barium is, I think, 279, no. 180, no. 966. 966. And what about the second ionization energy of barium? Mm, 502. I think 966 and 502. This is first ionization energy of barium, 502. So H2, can you tell me the value of H2?
So 502.
502. And what is H3?
966.
966. Now second element is sulfur, right? Sulfur is solid.
Sir, we are not using S8 over here.
No, because molecular form is not given. You can see that standard enthalpy change of atomization S is given. So
Okay, sir.
atomization means gaseous atom is formed, right? Sulfur gaseous is formed. Can you tell me what is it?
Sir,
Yes,
279. 279.
279. 279.
So, sir, we can't even use 1/8 of S8.
No, because sulfur is not in acid form, not given in the exam paper, right? Here we have sulfur, only sulfur, and the
Okay.
molecule is BAS. Are you getting my point or not?
Yes, sir, I'm getting it.
This is minus one gaseous. One electron is getting by it. Again, sulfur get S minus one. So barium plus two, gaseous. Now these two combine. This is barium sulfide. This is H1, H2, H3, H4, H5, H6, H7, H8. Yes, what is the value of H8?
Sir, can you scroll up?
Yes,
So it's minus 460.
minus 460. And what about the HS? S7 is required, right? So what is the value of H5?
So minus 200.
Minus 200. And then S6,
640.
640. Now tell me the formula. S7,
So H8.
H8. Very good. H1, H2, H3, H4, H5, H6, H7. Yes, H8 is minus 460. H1 is 180. H2 is 502. H3 is 966. Minus 200 plus 640. Yes, can you tell me the next value?
So plus X.
Plus X. Now find the value of X.
So we also had to add 279, right?
279. Yes. Can
So
you
sir,
tell
it's
me the
minus
value of
2827.
minus
Minus
2?
2827.
Correct. Minus 2827. Minus 2827. Now the second part.
So sir, we will cancel out barium and charge.
Okay. Barium is cancelled out. Charges are cancelled out. So sulfur versus oxygen. So which one is smaller?
So oxygen is smaller.
Oxygen is smaller. You know that oxygen, sulfur, selenium, tellurium. Yes. So latest energy of which one is smaller? Oxygen is smaller.
Yes, sir. Oxygen is smaller, so it will have greater latest energy.
Is greater than latest energy of. So latest energy of barium oxide is greater than latest energy of barium sulfide. Can you tell me why?
So the size of O2 minus is smaller than S2 minus, so mm,
Because size
the
of
forces of electrostatic attraction will be greater. So.
hmm, because source size of oxygen is smaller than size of sulfur. Any question?
No, sir, it's clear.
Okay, inshallah, tomorrow or day after tomorrow, I don't know the exact date. I think on Sunday, we will start entropy, last topic of this chapter, right?
Okay, sir.
Okay. No question at all?
No, sir, no questions.
Okay, thank you. Allah Hafiz.
Okay, thank you, sir. Allah Hafiz.
Allah Hafiz.